we go, a piecewise function in section 3.4, number 33. Okay, so we start by graphing each one individually. I like using colors to help me out. So I'm going to start with y equals x plus 3. So for y equals x plus 3, that means I start up 3, and then the that's the y-intercept, and then the slope is up 1 over 1, right? So you're talking about the line that's right in here. Okay, now we look at the domain that that one is defined for. Well, it says that that piece goes from -2 up to but not including 1. So we look at that line that we just graphed for that equation, and we find the point where x equals -2. So -2 is to the left too. So there's the point right there where x equals -2. And we have to put it on the graph of our line. And then we look for the point where x equals 1. But it goes up to that point but not including it. So that means there will be an open circle where x equals 1. So you go over 1 and go up to the line. And that's the portion of the graph for that piece. Then we take our next one. So y equals 5. The line y equals 5 is just a horizontal line at 5. So we go up to 5. 1, 2, 3, 4, 5. Horizontal line at 5. However, the only x value where it's defined is at 1. So where x equals 1, we go up to our line, which of course is at y equals 5, because that's all that y ever equals is 5. And all we do is put a dot right there. And that's the only portion of that function that we use. Then our last piece is y equals -x plus 2. That means our y-intercept is 2 and our slope is -1 over 1. So we're going to start at +2. And this time the slope is going down 1 over 1, so it's a line going like here. And on this one, the domain is x is greater than 1. So we look at where x equals 1 and go up to our line at that point, but it's greater than. So that means it does not include the point. We put an open circle there. Greater than means it's the x values to the right. Even though the line is going downward, that looks less than, but that's the y value. We're talking about the x value. The x value goes to the right, greater than. So that means the portion of the graph for that function is an open circle at 1, and then it follows the line we just graphed with an arrow going forever toward the right. Now for the question that someone else asked, which is how to find domain. We look at the point that is on the furthest left side of the graph, which is at -2. Does it include -2? Yes, it does. So the starting point is at -2, and then we go across and notice how every point is represented, even the point 1, because there's a solid dot there. So even though there's a hole there and a hole there, there's a solid point there that makes up for those holes. And then it continues thereafter and goes forever.
If that dot wasn't there, though, would you have to like put it to that point, or how would you do it?
Yeah, if this piece of the function was not there, which means there would be a hole here and a hole here and nothing to fill in x equals 1, then you would do the domain as 2 separate things. -2 to 1, parenthesis, and then parenthesis 1 to infinity. You just like break this into 2 pieces.
You wouldn't just put 2 and then 0, right?
No, you have to go up to 1. You just put a parenthesis so that you know it's not included. Yeah. Zach, any further question on that? Other Zach, we're good? Okay. Other Zach, Zach 1, Zach 2.